Whoop, whoop. Welcome. I don't know what I just did. Welcome from nothing to snake in 2 hours. I am Willem Delventhal. I am the headmaster of the Indie Game Academy. Can't quite, you got it. It's fine. The Indie Game Academy. And we are an indie studio accelerator or a video game accelerator. We take students and stick them together into teams where they then create and publish original games, monetized original games in just 3 months. Now, we also offer much smaller programs leading up to that big one, as well as free classes such as this one. So we are about to begin From Nothing to Snake in 2 hours. We love our From Nothing to Something in 2 hour classes. We've done Mario, we've done Flappy Bird. We will do even more in the future, but today is Snake. We are about 8 minutes before class is actually scheduled to start. So I'm going to turn off my video and my audio for just a second. I'm going to go get something to drink, maybe use the restroom before we begin. So if you're watching this after the fact, you can skip forward a couple of minutes when you start to see other people's faces. All right, be right back. All right. It's about time. Looks like we got 3 people waiting. I'm going to let them in. Hello. Welcome, everybody.
Hey.
Hi. Let's see. Great. Welcome, guys. So this is From Nothing to Snake in 2 hours. It is a series of different videos, interactive Zoom sessions, I should say, that we do on a number of different games. We've done Mario and Flappy Bird so far already. Today we're doing Snake. We will have more of them in the future, but for today, we're going to rock some Snake. If you guys are willing, I'd love to see your faces because it makes it easier for me to actually teach. Got another Dennis, 2 Dennises. All right. Hello, Dennis G. Wait, is this 2 Dennises or is this the same Dennis?
It's the same Dennis.
Confusing.
The one on Eventbrite, I couldn't see anybody else, so I came into Zoom.
Okay. Oh man, Eventbrite does weird stuff. Well, hi, man. How you doing, Dennis?
How are you?
I'm good. And hi, Morgan. How you doing?
I am doing all right. Give me a second.
Sure. Is that a Jurassic Park shirt that I see going on there?
Yes, it is.
Nice. It's one of my go-to workout shirts. Okay. So we have 10 people signed up, which usually means we're going to look for 4 or 5 to come to class. We'll wait just like a minute or 2 and then we'll actually get started. Why don't we poll the audience? Where are you guys at in your Unity or engineering experience?
My knowledge is pretty basic when it comes to Unity.
Yeah.
When I say basic, it's like foundational. I haven't used it at all. So.
Okay. How are you just, you're like excited to jump into it? What brought you to the class?
I wanted to get into game production and game product management, and I felt like it's necessary to understand how games are created in order to understand how they're produced.
Nice, absolutely. Do you know, are you from, how did you hear about the class?
David
Yes.
Dwayne, I think his last name is.
David Doan.
Doan, okay.
Yeah.
We were in the same game production class, and so
Nice.
he was advertising his game, and I was like, okay, I'll try it out too.
Nice. Yeah. That's funny. I was about to say I have a great contact for you, but it would be David. So
yeah, we talk here and there.
Yeah, that's great. Rowan, what about you? Where is your experience level at?
Well, I'm on step 3 of 5 out of the tutorials for the micro game.
Nice.
I thought I had installed Unity before. It was already like downloaded on my computer, but when I went to open it up, it prompted me to install it. So I guess I didn't finish the last time, because if I'm not mistaken, it's because it got me to the part where it wanted me to choose the game to start with, and I was like, no, and I closed it.
Good. Nailed it. Yeah, actually, so for everybody here, if you have not already done so, you got to download Unity, and it's a pretty big package. So do that like right this second. If you haven't, do you need help with that, Rowan, or are you already cruising through?
Maybe, like, so it's already started up. I've been fiddling with the 2D platformer tutorial. But when I went to open a new project, I got an error. I tried starting a 2D Unity project. Hold on.
So you can, like, you have it downloaded and you can open a project?
Yeah, yes. Like I'm doing the built-in project tutorial. But when I try to, hold on, let me try and do it again and see if I can get the error, because I already closed it. When I try to make a new one, I get an error about the package download or something not working. Which when I Googled it, the Unity forums say that that's something to do with a firewall, but I don't, it looks complicated in terms of how to fix that. So
you can or cannot open a project at this point?
I can't open, well, I'm trying now to do it again. Can
you make a totally fresh one? Because you're going to get a totally fresh one, we are A-okay.
Yeah, that's the problem. Like I can open the project that it opens for me, which is the 2D platformer micro game.
Okay.
The last time I tried to open a new project, it does this thing where it imports something, and I guess it's looking for packages from Unity, and it didn't work last time. I got an error message, but I'm trying to do it again, and I'll let you know if it goes through this.
Cool. Yeah. So I can maybe give you a tip for this one. This is the kind of thing that like you got to cross your fingers and hope things happen. Let me check in with Curtis here really quickly, and I'll show you something, and then we'll get started. Curtis, hello. Can you hear me?
Hear you.
Hi, Curtis. Are you willing to turn on your camera? Just helps me teach a little bit better.
Yeah, I can do that.
Awesome. So Curtis, where are you in your like experience of Unity, your level of experience?
I have participated in some game jams.
Okay.
And so I've worked with Unity a decent amount. I'm coming from the Work with Indies Discord. I was suggested to come here by Nate. So
yes. Oh, perfect. Awesome. So you're sort of checking us out.
Yeah.
Perfect.
Hi, Curtis.
Oh,
hello.
That's great. All right. So for Rowan, so we're going to go ahead and jump in now. For Rowan, the first thing that I'm going to show you, this is not necessarily the solution, but something that might fix what you have going on. If you go to whatever project you're trying to open itself, oh, you're hitting completely new though, and it's crashing.
Yeah, like hang on. It did it again. It says package manager window, error searching for packages.
Can you share your screen for us real quickly?
Yeah, let me try and figure out how to do that.
Bottom middle, if you hit share screen. For anyone else, so Morgan, you are downloaded A-OK. Dennis, you are downloaded A-OK. Curtis, you are downloaded A-OK. Yes, no, maybe so. Okay, so why don't you try this for me? Go to your console there, little tab in the middle, hit clear. All right. So this does not mean that Unity is not broken, but it does mean that you can probably at least follow along with this class. Will you hit play for me actually in the very top middle? You see the play button? Yep. Okay, you should be fine to at least follow along in the class. If we have some extra minutes at the end, maybe we can dig through it together. Your first lesson, everybody, you can stop screen sharing, Rowan. Your first lesson, everybody, is Unity is incredibly powerful, is amazing. But also, it is so big and robust and complicated at this point that weird stuff happens. It's a mystery. All right, so let's jump in. Let's make some Snake. First things first, my name is Willem Delventhal. I am the headmaster of the Indie Game Academy. Basically, we teach people how to run their own indie studios and make amazing games. And we run these free 2-hour classes pretty frequently because they're fun and because new people get to be involved in our community. So today we're making Snake. We are going to be, let me share my screen here. We're going to finish today with something equivalent to this. You can imagine that since we only have 2 hours to produce a game, it's not going to be the most beautiful version of Snake ever, but it is a functional version. Wow. Why is it running so tremendously slow? It is not going to, maybe because I'm screen sharing at the same time. It is not going to be the, what's happening? Hold on here, y'all. You know, we're gonna bug fix live. It is not going to be the prettiest version of Snake ever, but it will be a functional version of Snake. The whole idea with these courses is because we only have 2 hours to get through an entire game, it's really hard to get through an entire game. So what we try to do is give you sort of chunks of code that you can apply, as well as writing a little bit of code so that you get at least a sense of how C# works, but you're not really going to be building this entire game yourself because that's just sort of unrealistic to ask people who are fairly inexperienced to build an entirely new game in just 2 hours. So first things first, I want you to open up either Unity Hub or Unity, whichever one you downloaded. Although if you don't use Unity Hub, I highly recommend it. And when you have Unity Hub open, if you didn't already figure this one out, hit the new button. We are going to be building a 2-dimensional game Although to be honest, this is not strictly, this doesn't necessarily change how the game actually functions. It's not the end of the world if you hit the wrong one, is basically what I'm saying. But for this game, definitely hit 2D. And you can name your project whatever you want. I'm going to call this one Snake Tester. And I always recommend that you have a folder where you put all of your different projects in one place. I call mine my workspace. I'll go ahead and put my game in there. So,
question.
Yeah, Rowan, go ahead.
Does it need to be on your primary drive? Because I'm wondering if that might be the problem. Because I've got Unity installed and the new project started on my secondary hard drive.
I have not had that problem before, but that might be something that you could try. Yeah. I also typically develop on a Mac where you'll only have one drive anyway. So Unity here is what we call an IDE. Does anybody know what that stands for? Oh, geez.
If I recall, it's like integrated development environment.
An integrated development environment. If you have that pop-up, by the way, this is one of Unity's many amazing things. You should be able to just create a new one. Did it actually make it? Is this the one I just made? Or no? Here we go. We're having a fantastic start here, guys. Welcome to the world of tech. Yeah, so an IDE is an integrated development environment. And basically, you can imagine this kind of like a Photoshop for game development. Back in the good old days of making games, a lot of what you were actually doing was writing scripts and putting images in different folders, putting assets in different folders, and then running things out of those folders. So a lot of what you were doing was non-visual. It was sort of just editing the scripts and making them functional or non-functional. These days, we have what's called integrated development environments. There are a number of them out there. Unity happens to be the most popular one. And just for comparison, the second most popular one at this time is Unreal Engine. And Unity has about 65% of new games produced in it, just like all new games, versus Unreal at about 15 to 18%. So Unity really is completely crushing the market of game development. But there's a reason for it. And while it has bugs, which we have now experienced already, it is an incredibly powerful tool that does a number of things differently than anybody else. So before we even really get started, let's make sure, does everybody have a Unity window open, such as mine? Got thumbs? Are we good, Rowan? Okay, great. So I'm going to have you, if you are not already familiar enough with Unity to do it the way that you want to do it, I'm going to ask that you set up your screen the same way that I'm about to set it up. And that's mostly so that when I come and bug fix for you, it's easier for me. I am being lazy. So you'll notice in the middle, we have a scene tab as well as a game tab. And probably if it loaded the default layout, they're right next to each other as multiple tabs. That's stupid. I want you to click the game tab, drag it so that it snaps to the middle center. See what I'm talking about? Now we have two separate windows in the middle, one for the game and one for the scene. I need to do that. Curtis, we have you coming in again. All right. I also want you to do the same thing down here where we have our project and our console. Why do we have two Curtises now? All right, as long as it's cool. So I want you to do the same thing with your project and your console. Click and drag your console tab to sort of the middle bottom so that you have them as two separate ones, two separate windows. You should by default have your inspector on the right-hand side, your hierarchy on the left-hand side, your project in the bottom left, and your console in the sort of middle bottom. Now, one last thing, this is mostly personal preference, but I find it way easier to navigate myself. In the project tab, in the top right of that tab, you'll see the three little dots. That's the options for whatever the heck you're clicking on. At this point, it's the project. I'm going to hit that and change that to a one-column layout, which makes it more similar to Finder or File Explorer on PC. Okay, we have our IDE set up. So we're going to talk about what each of these little sections actually do, what each of these different windows actually does. First of all, Unity is based on what we call scenes. Anybody know what a scene is? And Curtis, I think you're just like not allowed to talk. I don't know. Maybe you can answer sometimes. Anybody know what a scene is? Or would you like to guess?
It's just like the instance in time and space where things are happening, I guess.
Yeah, I'll accept that. Yeah, a scene is the way we typically use it is probably as a level. So you would have different scenes for different levels of Mario or whatever the heck you're making. So you might make, scene 1-1, and that's world 1-1, and you actually design all of the level in that one scene. A scene is similar, since we're talking about Photoshop and the IDE, it's similar to like a single layout in Photoshop where you put a bunch of images on there and then you'd switch to a different layout and see completely different images. Right now, we have only one scene. What is the name of our one scene?
Sample scene.
Sample scene.
Sample scene. Good job. Yes. Checking your investigative skills. Yes, the sample scene. So you'll see that in two different locations. First of all, in the bottom left, we'll talk about this window first. This is our project tab. Our project is similar to the library in Photoshop. It is everything that we have access to in this project. So as we add scripts, as we add images, as we add all kinds of other stuff, it'll be in our project available to us to use in our different scenes. In the top left is the hierarchy. The hierarchy is everything that exists in only this current scene. So if we're talking about World 1-1 in Mario, there's going to be a bunch of Goombas and a bunch of bricks and stuff like that in there, but there's not going to be a Bowser, right? But there will be a Bowser in our project because our project is everything we have access to. Does that make sense to everybody? Cool. By the way, a little bit of etiquette here. Since we're a little bit smaller today, I don't think we have to worry about it too much. But if you have questions, please feel free to ask, but just try to be respectful of each other. Keep your mic off if you aren't currently talking. If you do have questions, please jump in because it's a lot easier for me to handle something quickly than find out that you're like half an hour behind later and try to catch you up then. So if anything's going wrong, just let me know. It is totally expected and is actually valuable to the other students. Because usually if something happens to you that's a problem, it's going to happen to them at some point. So better to just say like, hey, I don't know what the hell is happening, rather than half an hour from now, me find out that you don't know what's happening at all.
Do you prefer we interject or do we use the raise hand option?
Why don't we do a little hand raise? Because I can see all of you. It's cuter too. It's fun. All right. So next window here. Hi, Dennis. Next window here is our scene. And given what we've been talking about, what do we think the scene is? Come on, you got to take a guess. Morgan, you haven't talked yet. What's the scene?
I have no idea. Shaded?
Not quite. The scene tab, the scene window here, is basically our workspace. This is where we are actually going to be editing level 1-1 of Mario. The game to the right of that, given what I just said about the scene, can you guess what the game might be?
A preview of what it actually looks like.
Yep. So this is one of the really powerful features of Unity. If you've ever heard the term emulator or simulator, that's essentially what this is. This allows us to test and run the game from inside of Unity without having to put it on my phone or on a PC or wherever I'm actually going to be exporting my game to. So at any moment, this is what the player is actually going to see, our game. And you can see that it's a little bit different from the scene, which we'll talk about more. In the bottom here is the console where errors will pop up, which is why I always put it on its own tab, because I'd rather know about those errors than kind of not notice them. And finally, in the right is the inspector, where all of the information about the currently selected game object is displayed. So here is your first exercise. I would like you to click in the hierarchy on the main camera and watch the inspector drop a bunch of stuff down. Okay. So what you'll notice is that when you click on the main camera, the inspector populates with a couple of different things. The main thing that it populates with is a bunch of settings about the camera. So in the inspector, whenever you have something selected, there are all kinds of things that you can change about that object. And in this case, the first one that I want you to play with is actually the background color of your game. And you'll notice that on the camera, the second thing there is background, and it's a big block of color. If you click on that, it'll actually open its own little dialog window, and you can play with the background color of your game. So go ahead and choose a nice custom color for your game of Snake. Do like a, I don't know, let's see. Yeah, a little sky blue for me. Perfect. All right. Anybody having problems with that? Hopefully not. Okay, let's make our scene a little bit more interesting. So this is a game of Snake. Whenever we start building a game, typically, this is not always true, but typically the first thing that I would work on is my player and the way that my player actually engages with the world. So usually input, my player being able to walk around or whatever. So the first thing we're going to build in our version of Snake is the snake itself. But for now, just the head. We're not going to worry about the tail quite yet because that's much more complicated. And we're going to get the snake actually moving around because that'll feel great. So over in the hierarchy is typically where you're actually going to create what we call game objects. Any object that can exist in a scene as a standalone thing is a game object in Unity. And that's a term that they made up, but it's self-explanatory. It's an object in your game. So in order to create our first game object in the hierarchy, I want you to go up to that little plus button right under the name hierarchy and hit plus. You'll see a whole lot of options here, but given that we're making a 2D game, I want you to go to 2D object and then a sprite and then make yourself a circle. And you'll see that a circle magically appears on the screen. Wow. Anybody have any issues with this? Good, great. Okay. Anybody know what a sprite is? Let's get a little history lesson. What is a sprite?
It's just a 2D picture made of pixels.
Yeah.
Pixel representation of an object.
Yes. Yeah. So in today's day and age, when somebody says sprite, they mostly just mean like image. But where the term sprite actually originated from was from back when we had computers that had a dedicated amount of memory for their screen space. So imagine actual pixels across the screen that it's filling in with color. A sprite was a separate allocation of memory where the image would be drawn to and then displayed on top of the actual like background image, the actual set of whatever the heck is there, right? So in a game, what that meant is we could draw a background and then we could draw like Sonic the Hedgehog and move Sonic without having to worry about redrawing this background. It's not quite true. We would still redraw it, but it gave us a lot of versatility. And for a short period of time, something that computer systems would actually advertise is how many sprites they could support. These days, we can theoretically support infinite sprites. And it mostly, like I said, just means image. But that's where the term sprite comes from. All right, so we have a circle in our scene. And we'll notice immediately that it also appears in the game. What I want you to do before anything else is drag this circle, which you can do with a number of different tools up here. Right now, I'm using the Rect tool in the top left. The Rect tool is probably the one I have selected the most often. So let's actually, we'll do a quick rundown of each of them. All the way on the left is the hand tool. Like I said, most of your sort of game editing is going to happen in the scene window. This is like your workshop. So if you click into the scene window with the hand tool selected, you'll drag around the scene. But a hot tip for you, any of the tools that you have selected, if you right click, you will also drag around with it. So I don't really use the hand tool by itself. The next one is the move tool. Whatever object you currently have selected will have some arrows sticking out of it when you have the move tool selected. This allows you to move the object along one axis, the other axis by clicking on the arrows, or both axes at once by clicking on that box in the middle. Next, we have the rotate tool, which does what it sounds like. It has a circle along each of the 3 axes that something can turn around, because even though this is a 2D game, we can still manipulate stuff in 3D space. Another fun Unity fact for you is that Unity was originally built for 3D game development with no consideration for 2D, or at least very little consideration for 2D. And then when more and more people started using it for 2D games, they actually split up a lot of the logic and allowed you to make a 2D game versus a 3D game. So this 2D game that we're building is actually still 3D. And in fact, you can see that in your scene. If you click that little 2D button, that's actually a radio button to see the world in 2D or 3D. So even though this is a flat circle that we have in our world, it's actually in 3D space. And we can see that it's, infinitely thin, just like a flat 3D object would be. All right. So the rotate tool allows us to rotate around any of our axes, which is sort of hard to tell when it's a circle, but you can still see that it's rotating. The scale tool does what it sounds like. It allows you to scale this object along either of the axes or both at once. The Rect tool is probably the one I use the most because it kind of does the things that you want. It scales stuff in a way more similar to like Microsoft Word or maybe Photoshop, where you're grabbing the corners rather than scaling along an axis, which just to me at least makes more sense in my head. And then the little additional thing that they added to this tool for whatever reason is that if you click on the object with the scale tool selected, you can drag it. So this winds up actually becoming a tool I have selected the majority of the time. And then finally, the next one is the move, rotate, or scale selected objects tool, which is a heinous sin. And I have never met somebody who actually uses it, but you can try if you want. It does everything at once. All right, so that's your little introduction to all of the tools. So what I'd like you to do is take your little circle here and drag it outside of this white bounding box. And notice what happens to your game. What happened to the game?
It left the view of the camera.
Yeah, left the view of the camera. Perfect. That is exactly what I was trying to illustrate. Good job, Dennis. So yeah, this bounding box is what the camera is the camera of our game, which in pretty much every game out there exists. It is a thing that the player is seeing from, a perspective that the player is seeing from. And if we switch to 3D, we can actually see, and then select the camera, we can actually see its true bounding box going off into near infinity, very far away. All right, so we have a circle. I'm gonna reset some of these objects. You can manipulate many different variables in the inspector, including all of these transform things that we just messed with using our different tool sets. I don't really like the fact that my circle is all rotated weird, so I'm gonna manipulate all of them here in the inspector, back down to a just its standard. If you wanna do that quicker, you can also hit the 3 dots there on the transform and hit reset. So I have a set of resources for you. Let me get a link that will include a bunch of scripts and a bunch of pictures. And I'll drop this in the chat there. You can open that up and you can straight up download that whole folder. You can grab whatever images or whatever scripts from it. There's also a handout in there. Like I said, we kind of get through as much of this as we can in the 2-hour chunk of time, but oftentimes that's not the entire game because it's just hard to build something in 2 hours, especially when I'm explaining, what an IDE is and stuff. So there's a handout that you guys can check out. The intention of these classes is that you can do enough so that the game feels functional and that you can keep exploring and keep building upon it in the future. All of the scripts that I have available to you in the scripts folder here are commented to heck. There's tons and tons of comments in there trying to explain how they function. So this is where you guys can explore after the fact. For now, I'm going to ask you to follow me along. But one of the first things that I want you to do is go ahead and download this images folder. You can just right click and hit download. And once you have done so, we're going to import our first image into Unity. There we go. Took it a hot second. Now to import stuff into Unity, it's pretty dang simple. One of the things that's really nice about Unity. All you have to do is grab the asset that you want. And I say asset because it could be an audio file, it could be a script, it could be a picture. It does not have to be just an image. You're going to click it, drag it, and drop it straight into your project folder. And Unity will automatically duplicate that asset and put it into the project folder. So you can see I now have a snake head in my project. So I'd like everybody to grab a snake head from the images that I have available to you. Did everybody successfully import their snake head?
Mine's taken a hot minute to zip the file, apparently.
Yeah, I gotta unzip this first. Hold on.
All right, no problem.
Oh, I had a question.
Yeah.
Since the bounding box is basically infinite,
Mm-hmm.
does it, if you're working in 2D, does it understand like perspective? So could you put objects further back in that bounding box and have it understand that?
This is a fantastic question. So while you guys might as well, since it takes a little time to zip stuff, and since I have something to talk about now while we wait, why don't you go ahead and grab the images folder as well as the scripts folder. Don't import the script yet, because what I'm going to have you do is use some scripts that I wrote for you and write some yourself. So I'll ask you to import scripts one at a time, but you can at least download it onto your machine to have it ready for that. So I'm going to do that too. But while that happens, so the images and scripts folder, you can go ahead and drop all of the images straight into Unity, but hold off on the scripts for now. While that's happening, I will talk about orthographic versus perspective layout. So if we click on the camera here and we switch to 3D, we can see that this camera goes on, it's not actually infinite, it's actually 1,000 units, which is an arbitrary number, but just is as far as they happen to put it by default. We'll notice that if I click on this circle in the 3D space and I drag it further away from the camera, it does not care about distance. So this is what we call a orthographic camera. Yeah, this is orthographic projection, which basically just means distance is not taken into consideration. The one way that it does matter, and this is sort of interesting and a little bit weird. If I change this color to be red, and then I duplicate this circle and change this one to be green, let's say. If I move this circle, this green circle slightly to the side and they overlap, we'll notice that the green one is on top of the red one, right? And then if I move this red one closer, at some point it snaps ahead. So the whenever we're talking in the world of engineering, there's always edge cases, but majority of the time, the only way we really use Z position in 2D games is sorting or ordering. So what order stuff is on top of each other. In a perspective game, so if I switch to my main camera to perspective, which I can do quite easily, we'll see that this behaves more like a human eye and it actually cares about distance.
Wait, so how did you do that?
Literally on my camera, there's a drop down. That's why Unity is amazing. Yeah, we're going to keep ours orthographic for now, but there's your answer. All right, does everybody have some images in Unity?
Can you remind me how to import that? Do you just drag and drop it?
Yep, just drag and drop straight into your project folder. And it pays, this is going to be a smaller game, but it gets disorganized in here pretty dang quick. So it pays to keep yourself organized. Maybe make yourself an images folder, drop your images in there. Okay, so we are going to replace one of our circles. I'll delete the other one for now. Replace one of our circles with that snake head that I added. Now we're going to get the snake actually moving. So all we have to do that, you'll notice if I have this circle selected in the inspector, we have what's called a sprite renderer. Now, I know I'm doing a lot of sort of backgrounding, but this sort of helps you understand as you move forward. And this is part of sort of the idea of these courses. It's giving you a good idea of how Unity functions at a base level. So Unity uses what we call a component-based programming system. Has anybody heard of a component-based programming system? Curtis, what is it? What's a component-based programming system?
I don't know all the details, but essentially it's where there are like objects in your game. So like the circle is an object in the game, and every object has components, which would the components are what you see over in the inspector. So
yes,
essentially like the features of that object or the details.
Yeah, totally. Yeah. So it's a minor change to how we think about programming, but the more traditional way of doing it, the further back in time you go, there's many different ways we've done it, but the more traditional and recent way we've done it is what we call object-oriented programming instead of component-based. And object-oriented programming means when I program a dog, I write dog.cs and I put all the things in it about how a dog does. And then if I want to write a cat, I write cat.cs and I put all the things in it about how a cat does. In a component-based system, instead of doing those objects separately, even though they are tangibly separate objects, I'm actually going to write the individual components that would make up either of those animals and then combine them later. So I would write a leg script maybe, and a fur script, and like a bark script. And I would combine those to get a dog and to get a cat. So given that sort of explanation, why do we do that?
It's, what's the word? When you can put things together and you need less parts overall.
Yeah, more robust or more reusable.
There's a specific word for that and it's just gone out of my head. You use it in asset packs a lot, where it's like Legos.
Component
What's the word?
Things? I don't know. Well, at the very least, the sort of end result of it is that these are more reusable. These components are more reusable. So you'll notice that if you click on your main camera, we have a chunk of our inspector called the transform and a chunk called the camera. And if you click on your circle, you have a chunk called the transform and you have a chunk called the sprite renderer. Those are all components. So our main camera is built of two components, a transform and a camera. Our circle is built of two components, a transform and a sprite renderer. As we get more advanced, we're going to add a whole heck of a lot more than just two components. But that is how you can think about our coding as we move on. So we're actually going to write individual components. Today, because we're trying to move fairly quickly, we're only going to have one example of a true sort of component-based system. And we're going to actually start with it. So, well, let's do this first. So on your circle, I want you to go ahead and replace the image that we have there. And you can do that very simply just by editing the sprite renderer, the component that knows how to render sprites, with the correct sprite. So you can see at the top of the sprite renderer, it has an empty box that just says circle. That's a built-in sprite that Unity has available to you. If you click that circle, there's going to be a ton of different sprites available to you. Basically, every sprite that your project has available, including a ton of built-in ones. But eventually, you'll find your snake head in there. If you want something a little bit faster, you can also drag and drop any sort of open box like that in the inspector. You can drag and drop into, especially if it has that little circle that we saw there. So if I wanted to go a little bit faster, if I have my circle, instead of having to scroll through all of Unity's built-in options, which even though this is a little bit annoying, this is super nice because they used to not have any built-in options. Instead of doing that, I can click and drag my snakehead from down here in my project into that empty folder and drop it to make it reattach the correct sprite to this object. And the final way, this is a little bit different, but if I was making new objects in my scene, I can click and drag any of these images into my scene itself and drop it, and it will make a new game object. It will attach a sprite renderer to that game object, and then it will attach the correct sprite to that sprite renderer. So it will actually sort of make the object for us. Okay, so however you're gonna do it, I want you to add a snake head to your scene. Now, mine is absolutely humongous, but we know how to fix that. We have a scale option. Make that maybe like a 0.1. Yep, that looks about right. And mine is currently red because I was showing that stuff off. When you have a sprite with actual colors in it, it's going to do a color overlay. Once again, I'm using a lot of Photoshop language, but yeah, imagine like it putting a color on top of the existing color of the sprite. So you can tint objects, which is actually useful sometimes. You can make an enemy, a Goomba that's like slightly reddish in color to indicate that it's more dangerous. But if you make that color pure white, it will show exactly what the sprite is. All right, so we got a snake head. So I'm going to have us use one of the scripts that I already wrote for you completely from just using my script, not writing anything. But we'll talk about it a little bit, and then we're gonna write our own that actually utilizes that script. So from the scripts that you have downloaded, I want you to grab the mover script and drag and drop that into your project. And once again, it pays to be organized. So I'm going to make myself a scripts folder. And Unity may take a second to compile. Don't worry about it. I'm going to make myself a scripts folder, and I'm going to drop this mover into my scripts folder. Now, depending on how you have Unity set up, when you double click on a script, it should open your default script editor, which I actually still use Visual Studio, which is sort of their recommended one. I like it because it hooks up with Unity very well. There are people who use all kinds of different script editors though. This just happens to be the one I use. You can configure this. If you go to Unity, if you have Unity open, go up to the Unity menu, go to Preferences, and then you can see in the External Tools dropdown, there's the External Script Editor. You can browse for a new one in there. But like I said, I still like Visual Studio myself. Oh, I actually had it open already. Don't look at that, spoilers. All right. All right, so our mover is really-
Wait, hang on.
Oh yeah.
So when you double click on it, it's supposed to open it automatically in that thing?
Yep. It will.
If it doesn't do that, well, when I double click on it, Windows wants me to tell it what app to use. So
yeah, so you might not have one. Are you double clicking inside of Unity? Like in the project itself?
Yep.
Okay. So what you can do for now, you can. So one of the free ones that I like is Sublime Text. Visual Studio, I think, is actually also free, so you should be able to go download that while we're talking. What you can do for now, though, is if nothing else, you can open this just in any text editor. It's just going to be way more of a pain in the ass, but we can talk you through it. So you can right-click on the object and hit Reveal in Finder. Or in your case, it's probably like Reveal in File Explorer or Show Location. And you'll see your mover.cs here, and then you can open that with whatever you want. You can see that, even notes or text edit is a viable way to open a script. It's just that it won't have any syntax correction for you, which means you'll make a lot of mistakes. I recommend, though, downloading Visual Studio, so you can get that started while we talk about this. Okay, so I'm going to show off the mover script here. It's relatively simple, and I'm going to use it sort of as our so Rowan, we're not going to script for a hot second while I talk about this. So you can just look while we're doing this one. I'm going to talk about a couple of components of how a script actually works. First things first, scripts can be scary. I don't know how much engineering experience all of you guys have, but don't be scared. At some point, this will click. And for a long time before that, it will feel very confusing. Don't worry, I'm still confused. And I've been doing this for like 20 years or something. It's totally normal. It's okay. You're going to make lots of mistakes. That's fine. That's how you learn. Better to make the mistakes than to just not try, right? So at the top of your script, you're going to notice a couple of important things. One is whenever you make a new C# script, Unity will automatically add these 3 using statements. Now, I'm not going to talk about these too much, but these are basically importing libraries. They're importing actual code that Unity uses. There is one script that we probably won't get to today. It's one of the last ones that if we really cruised through, we could get through, but basically nobody ever gets to it, called the game restarter that you can look at that has a lot of comments about this inside of. The next section that you'll see in your script is the declaration of the class. You can see that it says public class mover, mono behavior. Now, I'm not going to talk too much about these because we only have so much time. But this is what we call an accessibility token. This is how accessible this object is. This object is public, which means everything else can see it, which is what we want. The second term there is a class statement, which indicates that this is a class, which basically means that it's a script. So we're saying this is a publicly accessible script, and it happens to be called mover. The last one there is this is where our script is inheriting from. A mono behavior is Unity's sort of built-in most basic thing. It knows how to do a number of different tasks, and any script that you write is actually going to inherit or sort of learn from that script. We're not going to talk much more about that. That's really like a 201 concept, so you don't need to worry about it. Basically, whenever you make a new script, it's going to say mono behavior. And if you are curious, you can go look up object inheritance. So this word is the only one that we actually wrote ourselves, which we will do in just a moment. And it's just saying that we named this class, we named this script mover. Now, what is the importance of a curly brace? Someone?
That sort of contains everything within that class. It
Yep.
denotes the start and end.
Yes, perfect. So whenever you see a curly brace, right, computers are not, they have no actual intelligence. They go by a certain set of rules, a certain set of logic. And as long as those sets of rules are hit, they quote unquote know what's going on. So in most programming languages, many, many different programming languages, you will see the use of curly braces. And you'll notice that those curly braces always have an opening curly brace, this top one, and a closing curly brace, this bottom one. These 2 curly braces on the same line, the same indentation here, are partners. They're an opener and a closer. And everything in between them is a part of whatever the line is above them. As I'm teaching this, I'm going to make some generalizations, but it's okay. So in general, at least, whenever you see an opening and a closing curly brace, all the script inside of those opening and closing belong to whatever the line is above it. Does that make sense? So everything inside of these two curly braces, which is the entire script, right, belongs to the mover, which makes sense. That's the script that we're writing. And everything inside these two curly braces, which is these two lines here, belongs to move in direction, which I'll talk about in just a second. What does the public float speed belong to?
Mover class.
Yep, the mover class. Does it belong to this move in direction? No. Yeah, easy enough, right? Okay. So our public float speed is what we call a variable. What's a variable, y'all?
It's a stored value of a certain data type.
Yep. Yeah, it's a stored value of a certain data type. This is what we call a float, which means a number that also has a decimal. So 1.5 is a float. And this is what we call a function. What is a function, y'all? It is a chunk of code that does something in particular. So here's what we're going to do. You are not going to edit the mover, but we are going to write ourselves a snake script. So remember me talking about object-oriented programming, we're going to take a slightly more object-oriented approach to this game so that we can get it done a little bit more quickly. So in your project, I want you to hit plus, and I want you to hit C# script. And then I want you to name this script snake. Now, many people have opinions on how you should do things. This is what we would probably call a controller. So some people might suggest you call this snake controller to make it more clear. But because you guys are a little bit less acquainted with Unity, and because I don't think it's terribly important, I'm just going to call this script snake. This is the thing that is the snake. It does the snake stuff. All right, so we have a snake script here. And we're going to do a little bit of an example of how Unity functions. So you'll notice that we have a start and an update function. So let's do a little example of what a function is. You don't need to type this section quite yet, but I want to show you a function. A function is a dedicated piece of code that gets some specific task done. So an example might be a sum function that takes in two numbers and spits out the sum. So this would be a completed function in Unity C#. If I wanted to use this function, I will then literally just write the name of the function plus any parameters that are required for the function to work, the things inside of the parentheses, on a new line. So in my start function, you guys, why don't we actually do this? This is a decent exercise. In your scripts, hopefully, Rowan, you have some sort of working script editor. Do you have something?
Working on it. It's
okay.
How did you
cranky about me installing it.
Uh-huh. Well, what's up, Dennis?
How do you open the scripts from the Unity editor again in Visual Studio?
Yep. So you, if it is downloaded and hooked up, which it may not be, you should just be able to double click on the script itself from inside of the project. Is good?
Yeah, I didn't hook it up to Visual Studio. Okay.
Okay, cool. But you do have it?
Mm-hmm.
Okay, great. Yeah, if you want to hook it up, you go up to Unity Preferences, External Tools. You can select your script editor. This class is, by the way, yes, it is recording. For a second there, I was like, uh-oh. So I'll put this up on our YouTube and I'll send it to all of you after the fact. So you can always come and check in on this. And you can reach out to me as well if you have any questions while you're trying to make stuff work. Like Rowan, if you're catching up with your broken ass script editor. But for those who have a script editor open, why don't you go ahead and write this function? We're not going to use it. We'll delete it when we're done, but it's a good example of how a function will work. So write literally public space int space sum with an uppercase S. It won't break, but other engineers will get mad at you. Parentheses int number one, int number two. So copy it exactly as I have here. Let me know if you can't see it. And then inside of your opening and closing curly brace, I want you to write return number one plus number two. And once you have this written out, I want you to actually use it. So we have two built-in functions. There are many of them out there, but whenever we make a new C# script, Unity automatically populates two built-in functions for us, start and update. The start function is called or utilized once at the very beginning of the game when this object first becomes created. The update function is called or used. Everything inside of it will happen every frame, which typically for a standard game means it's going to happen 60 times a second. So in order to see Unity working, and in fact, to do a very traditional coding exercise, in your start function, I want you to write debug, uppercase D, dot log, uppercase L, parentheses, quotation marks, hello world. Close it off with a semicolon. Whenever we have the end of a line in Unity, and in really many different programming languages, we have to close it. We have to let the compiler know, like, hey, this line is done. So we close it with a semicolon. For many of these other ones, for this line, for instance, we are actually kind of closing it, but we're closing it with our curly braces. So every line needs to be closed somehow, otherwise the compiler gets confused. So now we have a debug.log, hello world. And if we hit in the very top middle of our screen, the play button, this will start to emulate or run our game. And we'll see that in our console, nothing happened. Why did nothing happen, anybody?
Well, we didn't put anything in the start or update. It's right outside of it.
Not quite. So I actually, did you add this line here in the start?
Oh, well, what? Okay, I guess the second thing is, what's supposed to say hello world? Will it just appear in the console?
So it should have appeared in the console, yes, but it didn't. Anybody have guesses? Well, I'll let you know. No script is going to happen. It's just going to do anything unless it is actually in the world doing something. So right now we haven't actually attached our script to anything. There are classes or scripts that you're going to write that are not components, but the one that we just wrote is a component, which means it needs to be attached to a game object to actually function. So if we click on our circle, which I'll rename right now snake so it's more clear. If we click on our snake, we'll see there's an add component button. If you click that and start to search for snake, you'll see that your custom script is now one of the possible components to be attached to this object. And as soon as you attach it, when you hit play to run your game, you'll see hello world appearing in your console. Congratulations, you guys are game development gods. Wow. Rowan, what's happening? You look stressed.
It's downloading 2 gigs worth of data right now.
So at
it's
least
gonna be a while, and coding makes my head hurt. So.
Yes. Well, at least for now, I'm basically gonna have us write one script just so that we have an example of how scripting works, and then all of the other script, you're just gonna use my examples so that we can build it as quickly as possible. So if you want, while it will be a little bit more of a pain in the ass, you can absolutely just edit your script in a text editor. It will function. All right, so we have hello world. Do at least the other 3 have hello world printing?
I got errors printing.
Oh no, what do you have printing?
It printed.
Oh, okay. What are the errors?
I guess it's issues with what I wrote, I guess, in Reddit, like parentheses and the plus sign and the semicolon. So there might be something missing.
Yeah. Let's do a little pair programming here. Why don't you share your screen and we'll try to help you fix it.
All right.
I see your Funko Pops there in the corner.
They're chilling.
All right. So we definitely have some stuff going on here. So there are a number of issues. I'm wondering if either of the other two, if Rowan or I'm sorry, what was the last name? Rowan or Dennis?
Hi.
If you can help. Oh, you're Dennis. If Rowan or Morgan, if you can help. What's wrong with this script right here? Okay, so you fixed it at least partially. that was one of the errors. Yeah. Yep. But Rowan or Morgan, can you spot the other problem? There's still at least one problem. So remember that opening, in fact, what you were just clicking on, right? That's the opening curly brace, right?
Mm-hmm.
So where's the closing curly brace for your class? Oh, somebody spotted it?
Is sum supposed to look like that?
Sum?
Sum is inside of the parentheses. Isn't it supposed to be outside of it?
That is correct. I didn't even notice that one. Good job, Rowan. Fantastic.
A lot of spreadsheets in my life.
Good. So the other problem, though, is that opening curly brace. Where is the closing curly brace? That's actually not the closing curly brace. Remember that you know which one. There it is. Yeah. So where is your update right now?
It's outside of the whole class.
It's outside of the whole class. Yeah. So you can actually delete those two and move your update inside of that curly. There you go. That would work fine. Yeah.
Okay.
And it's very valuable to keep your indents the same, the correct. So you might want to indent your void update to be at the same sort of level as the other ones. There you go. And Visual Studio will do a lot of that for you, but it's not perfect about it, like you can see here. So this should actually work if you save this now. Also, always make sure to save your scripts. Sometimes you'd be like, I swear I fixed it and it doesn't work. Unity will take a second to compile. There you go.
Is there like a hotkey for play?
Actually, I don't know. I always just hit that. There might be.
Okay.
Hey, wow. It looks like you have two snakes on your object there. So you have my snake, my snake, and my snake. You might want to delete one of them. You can click on the three little dots to the right of it in the inspector. So click on the snake object.
Okay.
Click on the snake not that. Click on the snake object in the hierarchy.
In the hierarchy?
All the way on the left.
Boom.
Yep. And then you'll see in the inspector, he actually has two scripts attached to him, my snake and my snake. There you go. Yep. Remove component. Yeah, nailed it. All right, so you can stop sharing. We'll jump back in.
Okay. Do you know why the game screen, why that snake was like all pixelated?
Yes. And if we have some extra time, we can talk about it.
Okay. Thank you.
Yeah, want to get us moving. All right. So let's write some freaking code. So we have that working and we have this example function. So the only reason that I wanted you to write this example function was to get acquainted with typing stuff in and also to show you just how a function will work. So right now this function didn't do anything, right? We didn't see any numbers get added in the console or whatever, but we can make that function do something by, instead of saying debug.log hello world, we can delete those quotation marks and everything in between them and actually drop in the function itself with its own set of parentheses. Whenever you put a function in to utilize it, it always comes with parentheses. And then we can drop in two numbers that we want it to add because of these two parameters. So this is how a function gets used in most programming languages, but absolutely in C#. We type the name of the function and we put in the information that that function needs to work. So now if we hit run, that debug.log will still function, but instead of typing out hello world, the debug.log actually prints to your console, if that wasn't clear. It will now print out the sum of the function that you wrote yourself. So those are functions in Unity, a pre-written sort of chunk of logic that does something. All right, so for our snake, we are not going to need our sum function. We can delete that. If you want to keep it for nostalgic purposes, please do. I'm going to delete my own. And I don't know if we'll even use the start. We're not going to even use the start. You can go ahead and delete that as well. Instead, we're going to use this update function. Now, like I said, our update function, just like start, gets called automatically. We don't need to call it. Unity does that for us. But instead of happening once at the beginning of the game like start does, or more accurately, once when this object exists for the first time, update happens every frame. Which in Unity means it's typically happening 60 times a second. So update happens a lot. This is where we put input management. This is where we listen for keyboard presses. So we're going to do that right now. I want you to first make a reference variable. This is not inside of the update method, but it is inside of your class. So underneath your first opening curly brace, I want you to put a public mover. And you can name this maybe my mover. So that script that we wrote ourselves, even though I sent it to you and you put it in your project, that's a custom component, right? Even that custom component can be used as a type of variable from now on because we've defined it, we've created it. This is how scripts can get complex quite quickly. So we want a public mover, my mover. We're gonna do more with this in a moment, but this is how we're going to tell our mover, the thing that knows how to move, when to actually do the moving. Now inside of our update function, we're gonna go ahead and add some input. So I want you to type in if input with an uppercase I dot get key code dot, and this is where you can do whatever you want. I'm going to do left arrow, which is literally the left arrow key. But if you wanted to do WASD, you could add an A. It's going to be moving to the left, or you could do something else. I don't know, make it controlled by random letters. And then after, on a completely new line, after this if statement, you're going to need an opening and a curling and a closing curly brace again. So you can see that that got fairly complicated, but all this is a function, input.getKey, with a parameter, just like our sum. And the parameter that input.getKey asks for is which key you actually want me to listen for. In this case, it's the left arrow, right? So those building blocks look complicated, but really they're still pretty simple. Now, what is an if statement? Anyone? Or a conditional?
It tells the code to do something. If under certain circumstances, then it will do something else.
Yes. So you don't need to type this. This is an example here. But if I have a local int equals 5, and then I have an if statement that says if example int is greater than 3, I'm going to do stuff. Am I going to do stuff?
Yes.
Yes. Because why?
Because it's greater than 3.
Yeah, because 5 is greater than 3, and example int equals 5. Am I going to do stuff now?
Nope.
Nope, because 5 is not greater than 3. Excuse me. 5 is not less than 3. Yeah, so that's all an if statement does. It's conditional. Whatever is inside its opening and closing curly braces only happens if the statement inside of the parentheses is true. So in this case, what we're doing with our input is saying, hey, if this key is pressed, which in this case is the left arrow, I want you to do something. So in our case, we're going to do a few things. We're going to make ourselves another what's called global variable, a variable that exists to the entire class. And this one we will make private. And you'll see why that matters in a second. And we're going to call this private vector2 direction to move. So this is outside of the update, but inside of the class. Private vector2 direction to move. All right. Now we're going to use that immediately. Anybody know what a vector2 is? Or what a vector is?
Direction?
Mm-hmm. Yeah, so it's sort of interesting how it gets used in Unity. A vector is kind of like a ray, is an arrow in space, maybe.
It's
direction.
A mathematical path.
Yeah, mathematical path. But the way that people usually use it in Unity is actually more like a coordinate. It has an X and a Y. And the way that that gets used to indicate direction is if this is my 3 axes, my X, Y, and Z, although in our game, we're not really using Z. And I put that point in space, my X and Y up at 1, 1, that actually is indicating a direction from 0 to 1, 1. That's my arrow in space, right? But in this case, we are actually going to use it as a direction. In many cases, people use this just literally as a coordinate. My position is a vector2, for instance, because it is an X and a Y. So if we want to move to the left, we have to set our direction to move to indicate that we want to move to the left. So inside of my if statement here. I'm going to say direction to move equals new vector 2, and then an x and a y. And in this case, if I want to go towards the left, I need a negative x, because once again, my coordinates, negative x to the left, positive x to the right. So I'm going to put a negative 1f in my x coordinate and a 0f in my y coordinate, because I only want to move to the left. I don't want to move up or down. Does that make sense to people?
Why F?
That's just a C# convention. It's to indicate that this is still a float, which once again is a number that has decimals. The alternative is an integer or an int, which is a number with no decimals. Vector 2s just happen to use floats rather than
if you wanted
integers.
to move up or down, what would you do?
You do a y instead of an x. So this is our x, the x direction we want to go. So -1 that way. And the y direction is 0. Yeah. So we'll do that right now, actually. So you can, assuming you have this correct, you can go ahead and copy this whole if statement and paste it 4 times. You wishing you had a code editor, really?
Yeah, I'm just gonna have to like follow along and try this on my own afterwards because I'm too far behind to type all this in.
Yeah, that sucks. Well, I'll give you my email, and I will also email all of you guys the video of the class. So this is your warm up. We'll say this is your appetizer. All right. So we have our left arrow going to the left. We can change one of these if statements to be a right arrow. And then how do we modify? Oh boy. Just key code dot right arrow. How do we modify this vector to go towards the right instead of towards the left?
It would be 1, wouldn't it?
Yep, just a 1 instead of a -1. And then we can change one of these to up arrow and one of these to down arrow. And let me just make sure I'm not going to mess these ones up for you.
Do you actually need the spaces between the parentheses and the words, or are you doing that to increase legibility?
Like which ones?
Like at the very top one, get key parentheses space key code.
Yeah, so that is, you can see like I did that manually, but my script editor did not want me to do that. And it did it without the spaces. White space, once again, there's like always some edge cases, but 99% of the time, white space, meaning new lines, spaces, tabs, will be completely ignored by the compiler and it won't care about them. So it's just my personal preference, like you're saying. It's me feeling like this is easier to read. But that's actually a hot debate among engineers. So for my up arrow and my down arrow, I don't want any X movement, right? I only want to go along the Y axis, which is up and down. And instead, I want a +1 to go upwards. A higher Y is a higher in space. And a -1 to go downwards. All right.
So if this was in 3D, would it be 3 digits? So digit, comma, digit, comma, digit?
Yeah. So here I can show you that really, real quick. But if I made a new vector 3, we have an X, a Y, and a Z. Just like that.
So why'd you put a decimal after those? Does it make a difference if it's in 3D versus 2D?
A decimal after these? Oh, just like that?
1 point, yeah.
No, it doesn't matter. It's just me typing in different ways as I go. But if you wanted to be, this is like, some people might actually get upset about that, I guess, because this is even more clear that it does have a decimal. But the F already indicates that it is a float. And we use a float for positions for granularity's sake. Because if I only used integers, I could only be on 1 or 2 or 3. I can't be, all the spaces in between. Okay, so I don't want to use up too much time here. Normally, I would have you try to run this and you'd be like, okay, my guy is still not moving when I hit arrows. What the hell? But that's because we are storing the direction to move, but not actually utilizing that direction to move yet. So given the script that I already gave you, what do you think we have to do to actually make this thing move?
We have to attach it to the snake.
To the state?
Snake?
A snake. Yes, but not quite. You're totally right, but you were skipping a step first. What do I have to do in my code?
You need to use the variable somewhere.
Yeah, use this variable somewhere. We prepared this variable. We know which direction it's supposed to move us. but we aren't actually like using it. It's just like existing, but doing nothing. So this mover class that I wrote for you guys will actually knows how to use that direction. So after the if statements, but still inside of your update. So be careful with your curly braces. After your if statements, still inside of your update, I want you to add in your mover, my mover, dot. The mover itself has one predefined function, which is move in direction, which takes in one parameter, which is a vector2 direction. So what do you think we have to do here?
Get direction?
Yeah, we got to do my mover dot move in direction and then pass in direction to move, the thing that we actually prepared. So this mover now is actually going to do the work of moving us. So all the snake did is decide which direction to move, but the mover actually does the moving. So this is the component-based system that we're talking about, a different mindset. The mover is the thing that knows how to move, so it should be the only one actually moving. The snake knows how to like what direction to go, but it doesn't know how to move. It still tells the mover to do that for it. Does that make sense? Cool. All right. So this script, you have all of these available to you. So you can just straight up copy the one that I have. It has extra stuff in it because there's a lot of steps for us to get through. So it may crash, but you can totally open up the scripts that I have available to you if you're having trouble coding or if you have some compiler error you can't figure out. But now, Dennis, I am going to attach my snake script or component to my snake object. Which we already actually have. We don't need to worry about that. But we don't have a mover. So on my snake, I can hit add component and type in mover and add that sucker to my world. And then we'll notice that the snake wants access to the mover. And it says my mover, but then it just says none next to it. What do you think we do about that? What did we do with the sprite when we wanted to replace the sprite?
We'd have to add in a new sprite.
We drag and drop. So on our snake component, great guess. On our snake component, we have the my mover, it's just an empty box. We can literally click and drag this component, the mover component, and drop it into that box. So if you remember me mentioning that the my mover is a reference variable, it's still a variable and it's kind of a fine line. But whenever somebody says a reference variable, what that means is it's a variable that doesn't include unique information. Like our, what's an example? Our direction to move includes unique information. It's actually storing what direction we want to move, right? But the my mover is referencing something that already exists. That information is already out there, which is this mover. This is a huge part of the way that Unity works. Because we have multiple components, those components need to communicate with each other and know about each other. So what we've done now is we've given the snake script, the snake component, access to the mover that is on our game object and already exists. We did not make a new mover. We didn't do anything like that, but this mover now exists in our world. Now, to save us a little bit of time, your mover is going to like shoot off the side of the screen. So you might want to turn down the speed of your mover. 0.01 seems to be about the right speed. If you leave it at 1, your game of Snake is going to be like F0x or something. But now, as soon as we hit play and hit a direction, assuming we did it right, we actually now have a little moving happy snake guy. Dennis seems to have everything working perfectly. So for Rowan, you can attach the snake object that's there in the game. It has a couple of other things that it wants access to. But I don't remember exactly what it's going to want. It's going to want a trailer renderer. Oh, and a snake boot prefab. Okay, so not quite yet, Rowan. Apologies. Your snake won't quite work. Unless you want to get into your text editor. All right, so Dennis, where are you at with this? And Morgan, where are you at with this?
I guess I got to figure out the bugs.
All right, so let's do one more screen sharing exercise. Go ahead, Dennis, open it up. Try to fix it.
Probably a lack of brackets, but
that's okay. Yeah. Dude, don't worry about it, man. We're all learning. All right, so we have an update. That looks pretty clean. What is it complaining about in Unity?
I'll try it again.
Okay.
Oh, that's
So-
a lot of errors.
That's a lot of errors. So whenever you have errors, what I want you to do, Dennis, before you do anything else, go to the very top error. It looks like it's repeating itself over and over and over again.
Yeah.
But when we have multiple errors, sometimes those errors are actually cascading. So it's causing, the first error is causing the next error is causing the next one. So always solve your errors in chronological order. Now you hit clear, but those were actually all the same error. And the only error that it was saying was object reference not set to an instance of an object. That sounds big and intimidating, but that's actually the best error in Unity because it's the simplest to solve. So object reference not set to an instance of an object. For Morgan or for Rowan, can you guess what that might be trying to say?
It doesn't think that it's attached to the snake head.
Yes. Yeah. So it is saying that something is not correctly attached in the inspector, which there's only one thing on our snake script that we attached, which is what?
The script.
Yeah, the mover. So you see how my mover is still empty?
Oh, okay.
Yeah. So hit add component there. You don't need to do that quite yet. Hit add component. Yep. Search for mover. Yep. And drop that in. Great. And then you can actually drag that component, literally click on the name mover and drag it into that box there under my snake.
Under my snake. Oh, okay.
Yep. So you see you've now attached it. This is what I was talking about with a reference variable. So now my snake knows about that mover. You also, just because this thing will like shoot off the side of the screen really quickly, click on your snake again and change your speed down from 1 to 0.01. Yep. There you go. All right. And by the way, it is pixelated because you are literally zoomed in. If you see on the top of your game, there's a scale bar. I thought you had a more complicated problem. Otherwise, I would have told you that earlier. There you go. Go ahead and hit play now and it should work just fine.
Okay.
Oh, that was running the whole time. Click on the snake for me. I just want to make sure that everything's saved.
Yep.
It did not. Great. Okay. So this is hit play again. This is
okay. Hit play again.
Yeah. Like stop playing. This is a big thing in Unity that will happen to all of you. So don't worry, Dennis, you're helping everybody learn. You see how it just completely undid what you just did? Yeah. What the hell? So the reason that it did that is this is a intentional design that the Unity engineers did. When your game is playing, which your game was, you were actually running the game, you were emulating the game. It intentionally does not save changes to the inspector. And it does that so that you can edit things, so you can play with things, manipulate things without being worried about losing work. So something that I always recommend that I'll have all of you do now, in the top left of your screen, Dennis, under File, go to, or I think it's under, let me remember what it's under. Under Unity, I'm going to hit Unity Preferences.
Where would that be?
Click into the Unity window.
In the Unity window.
I think it's under edit for Windows users.
Oh, okay.
Okay, yeah.
There you go. Preferences. Yes, thank you guys. Perfect. So now under colors, hit colors there.
Colors?
Yep. So this allows you to edit what Unity looks like. The only one that I really want you to care about, that play mode tint. And it's sort of sitting by itself towards the top. It's gray right now. Play mode tint under general.
Under general.
You have it. All right. You were just, no, go back. You're almost there. Click on colors. Colors.
Okay, colors.
Yep. General, play mode tint.
Thank you.
Click that guy.
Okay.
And then change that to a color. You can just click on the box and it will open up a color dialog window.
Okay.
There you go. Change that to something really obvious. You see, whenever I hit play, my game becomes totally red, right? I do that because then I know I am currently running the game and I shouldn't mess with things that I don't want to save. So now your game will be this nice like goldenrod or something, right?
Oh,
That's a little bit more obvious that it's currently running. So if your game is now yellow or whatever you guys change it to, don't edit stuff in the inspector that you don't want to save. So really quickly to fix your problem again, hit on your snake, click on your snake.
Snake.
Add component, mover.
Add component over here?
Under the add component button. Yep.
Okay.
Mover. Yep. And then you can drag that guy into the my mover. Yep.
Okay.
And then change your speed to 0.01. And now you'll have a moving snake. Okay. Hit play, and let's just confirm that that works actually before I leave you. Hey! You can mess with that speed and stuff. Great. All right. Yep. So you can stop screen sharing now. Okay. So we have done enough so that we're just going to utilize some of the scripts that we actually have available to us. You hopefully, this is a very quick intro. You guys are definitely going to have to continue to play with this. And don't be too worried. Don't get frustrated. This took me years and years and years and years to really get comfortable with. So now that we are at least semi-acquainted with how the scripts work, we're going to just start to use the scripts that I already have available to you. So the next one that I want you to add to your world is the Apple script. Drag and drop your Apple script into your scripts folder if you haven't already done so. And the image if you haven't already gotten that too. And you can grab your Apple and drop that into the world. Holy cow, that's a big asset. And scale that down so it looks about the right size next to the snake. Looks like maybe 0.05 for me. Even that's really big. Wow, that's a big apple. There you go. About 0.25 looks about right for me.
Oh, wow.
One heck of an apple. And once you add your apple to your world, there's a giant apple. Yeah, go ahead and make it smaller. Make it, about the same size as your snake head there. Okay. When you have your apple, I want you to hit add component and add that Apple script that we just attached to it.
Quick question. Where is the Apple script?
So that would have been in the Google Drive that I gave you earlier, wherever you downloaded all the other scripts.
I've got two scripts, and one is mover and the other is mover.
Are you looking at the right folder?
Well, so I downloaded the whole thing, and it's got a folder that's images and a folder that's scripts.
Yeah.
And I've got all of the images. And then when I go to the scripts folder, it has mover and mover.cs. They are different scripts. I just noticed that because part of what was tripping me up is that my script did not look anything like the moving script that you were using. So maybe they're just named differently.
That is quite bizarre. I don't know if that is maybe some kind of virus protection or something. It's worried about you downloading CS files. You can, because they're pretty small, I don't think it'll even zip it. If you go to the Google Drive and go into scripts and just download them one at a time. So click on Apple and then hit download. That should just straight download a CS file and then you can grab it from there. While that's happening, we'll notice that on the Apple script, there's a couple of things that the Apple is expecting that it doesn't currently have. What are the two things that it is expecting that it doesn't currently have?
Score and a player trail.
Yep. Yeah. So the way we're going to do the tail in our game is we're going to use what's called a trail renderer. And the way that we're going to do the score in our game is what's called UI, is text. So let's start with the UI because that is a very useful thing to know. In your hierarchy, and Rowan, have you gotten the script?
Yes, hang on.
Okay, great. So in your hierarchy, I want you to go up and hit plus, go down to UI, and add text to your world. You'll notice a couple of things happen almost immediately. First of all, this massive canvas, if you double click on anything in the hierarchy, here's another hot Unity tip for you. If you double click on anything in the hierarchy, it will move and scale the scene so that you're looking at it appropriately. And you'll notice that this canvas is freaking massive. This is sort of, I've always thought this is weird, but you'll notice that when you zoom out to the canvas, your text is probably in the bottom left currently, but it still appears in the game at the correct size, right? So I don't know exactly why they do it this way. It has always seemed a little bit odd to me, but basically they make the canvas absolutely massive so that it's sort of in its own space. Our game is down there nice and small, and then our canvas is like way the hell out here. so that they're not interrupting each other when you're trying to edit your game. You can do some stuff about that, but for now, since we are coming close to the end of class, not going to worry about that too much. So our canvas, if you double click on it, you can zoom out to see the entire canvas. Now, once again, to save time, just to quickly cover this, the reason that we have a canvas and we don't just have a text object by itself is that the canvas actually wraps around all of our UI so that it can correctly scale to different screen sizes. As you guys get more into engineering, you're going to discover that screen sizes and different device sizes are the bane of your existence, and they are awful. But canvases are one of the things that will actually help you handle that. So the canvas gets stretched to fit the screen sizes under control of a couple of different ways you can edit it, such that it looks better compared to the different screen sizes. So what I want you to do is take your text object and put it, towards the top left of the screen, or I guess wherever you want your score to be displayed. Just drag it up towards the top left.
Trouble moving my canvas.
Your canvas cannot be moved.
Oh, so
your text can be moved.
How do I move my? Do I make it smaller?
So double click on your text until you have a good view of it. Right, here's my text object right here.
Oh, there's my problem. I don't have any text.
Aha. So yeah, you can on your canvas. Make sure so here's one more thing for you guys. You notice the text is underneath the canvas, right? How it's sort of indented. That's what we call a parent-child relationship. So this text is now actually a part of the canvas. And there are other ways that we might use that in the future. So the text object needs to be underneath the canvas. All UI needs to be underneath the canvas for it to actually be displayed. So when you make a new text object, just make sure you actually drag and drop it. I
guess my concern is that the canvas is only covering a quarter of my view.
That is normal.
Bounding box. Okay.
Yeah. So that's the thing that I was talking about, where they made it super freaking huge to try to make it in a sort of different space than the rest of the objects in your world. If you double click on the canvas, you'll see that you zoom way, way, way out. And it's actually much bigger than it appears. Yeah. So now you can attach a text object to it and move that somewhere. This text object has all kinds of different stuff that you can do to it. So I'm going to go ahead and write in score 000. You'll see you can change the font and the size and all the typical text stuff. But I'm going to mostly leave this normal since we're coming towards the close. Once we have a text object and we're satisfied with where it is on the screen, we can drag and drop that text object into the apple itself. The apple script, it has score text, a little box, right? We can drag and drop the text object into that box. All right.
How are you able to visualize your text on the game screen? My canvas is overlapping my game screen, but I don't see any text at all.
Yeah. So why don't we just do this? All right. Let's make it simpler. This is something that I wasn't going to cover for the sake of time, but it makes, to me, canvases far simpler to understand, at least early on. So on your canvas, when you have it selected so that you're seeing all the inspector objects about your canvas, all the inspector information about your canvas, you'll see under the canvas component, there is a screen space overlay dropdown. If you change that from screen space overlay to screen space camera, it's then going to want you to add a camera under render camera, which you can drag and drop your main camera into. And upon doing so, your canvas will shrink to the size of the rest of your game. And now it'll all be in one place. This is generally how I recommend people edit it. The screen space overlay is nice for a number of reasons, but it's weird. It's weird that it's just this massive thing off on the side. And I find, especially for new students, the screen space camera makes a little bit more sense.
That was much better. Thank you.
Perfect. Yes. Awesome. One thing for you to do here, actually, you see that plane distance? This is literally how far away it's drawing the stuff. Change that to 1. Just because then it's drawing the stuff right in front of the camera. So it's less likely that your game is going to get in the way of your canvas.
Is that for a canvas setting or a text setting?
So that's on the canvas itself. There's a plane distance right underneath the render camera that you dropped it into. Change that plane distance from 100 to just 1. All right. Rowan, where are you at? Morgan, where are you at? Do we have text? Morgan's just cruising along. I don't even need to check on him.
Theoretically, I have text, but it's still invisible. I did change the thing.
Okay. So let's, this is probably a great opportunity for learning. Are you comfortable sharing your screen?
Yeah, hang on. So this is it, I guess. I was able to find it by double clicking on it in the hierarchy.
Yeah.
I guess maybe I made it too small. Yeah, there it is.
Oh my God, it's teeny.
Well, so, yeah. it was huge, so I made it smaller. And then I guess when I reset my canvas to be the thing, it shrunk it accordingly.
Nice. Yeah, so this is something.
There it is.
There you go, perfect. That's exactly the learning moment that I wanted for everybody else here. If your text object is too small for the text size that you have inside of it, it will just straight up not display it. So if you ever see your text and it's just like invisible, it's probably just because the bounding box is too small and or the text size is too big, the font size. Okay, so now you have a little score. Great. You can stop sharing now. So our snake head, or our apple has those two empty boxes that it's waiting for, a score text and a player trail render. You can drag and drop that text object from your canvas right into that score text box. And now the apple will know about talking to the text object later. And I'll show you that working in just a second, because first we have to get our snake with a trail render, making it look a little bit more like an actual snake. So on your snake, I want you to right click the snake object and click create empty. And you'll notice that when I right click on the snake and hit create empty, that I wind up with a game object as a child of the snake that is actually underneath the snake, right? It's indented. You'll know you did that correctly if it is indented. We're going to use this to attach our trail renderer, the actual thing that's going to look like our tail, and so that we can actually position it relative to our parent. So you can name this empty object trail renderer or whatever makes sense to you. This is going to be the tail, basically. So you can maybe just call it tail or something. And you'll also notice that because this is an empty object, the only thing that it currently has is the transform. So even an empty object still has a transform component, because the transform tells us where in the world it exists, and it couldn't possibly exist in the world without one. So on my trailer renderer object underneath my snake, I'm going to hit add component, and I'm going to search for a trailer renderer and attach a trailer renderer. Now this will actually immediately work, though it will not do quite what we want, but you can test that everything is currently working by hitting play and starting to go. So my snake is horrendously ugly and horrendously slow, but it does seem to be functional. Okay, so let's fix this trailer render a little bit. There's a couple of things going on. First of all, this red line here at the top of the trailer render is how wide our trailer renderer is. I have found that for the size that I made my snake, 0.5 is about right. I can literally click that tiny little box there and change that to 0.5. And this is also a curve that we can actually play with. So if I double click anywhere on this red line, it will make a new node that I can actually move around. And this represents the lifetime of the tail, how thick it actually is. So if I move this down to maybe like halfway, and then I hit play, we'll see that the head of the snake is thicker than the back end of the snake. So you can play with that. Another one you probably want to mess with is the end cap vertices. We can see that the end of my snake currently is completely flat. And that's because there are currently no vertices or points in space to draw a curve along that edge of the tail. So if I make my end cap vertices maybe 5, the higher it is, the better the curve will look, but also the more expensive it is on our CPU. If I make it 5, that starts to look pretty good and make it a little bit more rounded. Now we got a snake who's moving around. It's all coming together now, y'all. All right. Everybody have a trail happening? Rowan?
I do not, but my snake doesn't move, so
Oh,
it's
no.
okay. I do have the thing attached and I changed the color, but there's no way for me to see if it works because my snake can't move.
Okay, so I'm going to get these guys to a point where they can start to do a little bit more work, and then we can check in together, Rowan.
There is a strange thing that happens when I press play, which is if I hit any of the arrow keys, my apple moves to the snake. I don't know why that's happening.
Okay, so I'm going to get the two of them to a point where they can actually work on something, and then we'll check in together. So one or two more things before I check in with Rowan. Under materials, you'll notice that your snake is currently bright pink, even though the color is currently listed as white. And that's because the trail renderer is actually, in fact, this is sort of an interesting little moment. The trail renderer is actually a 3D object that it's drawing in 3D space. So if I hit that 3D render or that 3D like toggle, we'll notice that this trail is actually 3-dimensional. So in the world of 3D, we use what we call materials. And essentially, this is not quite true once again, but essentially a material is a texture. So right now, our trail has no texture. And the way that Unity by default tells us that there's no texture is a bright pink ugly thing. So on our trail, we'll see a little materials drop down. We can hit that little arrow to drop it down. And it currently says element 0, none. It has no materials, no texture, therefore it's showing us a pink thing. If you hit that little circle, you can just hit that default line material, and that'll work just fine for us. It'll totally do us okay. But if you wanted to add like a snake skin texture to this guy or something like that, you could try making your own material. That might be something that you play with later. And then to make this more snaky, you can also play with the color by hitting the big block of white there under the color. And this is a little bit different than the colors we've played with before because it allows actual gradients. So we have a number of corners where we can play with the color. If we click on any of these little like arrow things and double click on them, it'll open up a dialog box. And then we can actually have it transition. So now mine is going from green to white. Now when I hit play, I have something that looks a whole heck of a lot more like a snake.
But it's on top of the head.
It is indeed. So, Rowan, you asked this question a long time ago. How do I sort things in 2 dimensions?
One of them needs to be closer to the camera.
Yes, brilliant. My God. Yeah, exactly. So in the world of 2D, we use the Z position to actually sort stuff. So the trail render is currently exactly attached to the snake, which means it will move with our snake wherever it goes, even if we moved it closer to the camera. But we can move the trail itself further away from the camera and therefore put it behind the snake. So I can actually drag this one. It doesn't need to be far, just like 1 away. If you make the Z position of your trail renderer 1, that will be far enough behind the snake head that it will draw the snake head on top of the trail. So there we go. All right. My God, before a 0.1 speed seemed fine, but now it is so slow. I'm gonna crank up the speed on my mover. Remember that you can do that. Now my speed is 0.05. Now my snake is much more reasonably speeded. Okay. And you will also notice that that trail is super, super long. And this is kind of confusing, but actually important. On your trail renderer, that time variable is actually how long the trail is. Anybody guess why it's called time and not like length or something?
Each emitter exists for a period of 5 seconds or 5 frames or whatever.
Wow, that was beautiful. Yes. So in our case, the way that our script expects it to be written, change that to 0.5. change the time to 0.5. And now you'll have a little stumpy tail. But as soon as we start eating this apple, it will work correctly. All right. So let's make it so we can eat this apple, and that might be where we get to today, and then you will have extra stuff to add yourself later. So currently, when we run into this apple, nothing happens, right? And that is because we currently have no collider attached to either the snake or the apple. So Unity actually does not know that we want these things to collide. We can make them collide very easily. So on our snake, I want you to click on your snake, hit Add Component, and search for Circle Collider 2D. Now remember that I said that Unity was actually designed for 3D first, and then it was sort of modified so that it would work well with 2D as well. So whenever you see a component that says 2D next to another component that doesn't say 2D, so here's our box collider and then our box collider 2D, that standard box collider is for 3D. And if you use the 3D version, it will do weird janky shit that you will be very confused about. So make sure you use the 2D version. So I want you to find yourself a Circle Collider 2D and attach that to your snake. You will know it's working correctly if you have a very transparent little green circle around your snake. And that is the collider. That is the thing that will actually run into stuff. You can modify that using your radius or your offsets. It's something for you to play with later. So you can see if I make my radius more like 4, it's a little bit tighter to the snake, which is probably what I want. Now I can do the same thing to my apple with my apple selected in the inspector. I'm going to hit Add Component, Circle Collider 2D. And once again, that's maybe like a little bit big, but we can always shrink that. 15 looks about right. And now if I hit play, I don't know why my apple is teleporting to me. Oh, I do actually. Okay, this will fix part of your problem, Rowan. Mm-hmm. On our apple, the way that this script works is in order to simplify things, the apple is not a new object. Every time we touch it, it's actually using the same apple again and just placing it at a different position. So that respawn bounds is actually how far to either side it's allowed to spawn. And currently, because it defaulted to the value of 0, it's only spawning in the exact center. Its respawn bounds are 0, 0, right in the middle of the screen. So we can test how far our bounds should be just by moving our apple over to the edge of the screen. And it looks like somewhere around maybe like 3.5 is probably what that value should actually be. And now when I hit play, we'll see that it does appear at a random position, but it appears at a much more correct random position, somewhere within our screen space. But we still can't touch it, even though our apple has a circle collider and our snake also has a circle collider. So this is something that wouldn't be obvious if this was the first time you were doing it, but in any collision in Unity, you need both a collider on both objects, which is the thing that literally impacts the component that says, hey, I hit something. And you also need what's called a rigid body. A rigid body lets Unity know that you want this thing to be subject to physics, that you want this thing to have physics. And collisions don't work if you don't have physics. So on our snake, you don't need to do it to your apple. Just on our snake, I want you to hit Add Component and search for Rigid Body 2D and add a Rigid Body 2D to your snake. And now when you hit play, what happened? Can anybody guess what just happened?
Physics. It's because of the
gravity. Yeah, we told it to do physics, and so it has gravity, and so it fell to the ends of the earth. But we could actually modify how gravity affects our snake. So on our rigid body component, right? Don't be scared to play with all of this. We'll see that there is a gravity scale. And you can turn that to 0 to effectively put our snake in space and have gravity not affect it. And now it will be able to move correctly, and it now knows about collisions. So I'm now running into this apple. Is Rowan, is your thing moving now or no?
No, I haven't messed with the script yet. So I have the correct mover script, but I will need to edit it, and I don't know how to code, so I would need your example of it.
Yes. So we will, how about this? What step are we on now? At the very least, you and I can spend a couple minutes at the end and get it working if we don't get it working in the next couple of minutes. Sound good?
Mm-hmm.
Okay, cool. So we now have a snake running into an apple, but it's actually still not behaving the way that it should be. The normal way that it behaves in snake is that we touch the thing that we're supposed to go get, our snake gets longer, the apple disappears and goes somewhere else, right? So it's still not doing that, we're just running into it. And there is a subtle reason why. This is another thing that I've always found a little bit odd. I think it's a strange decision on the part of the Unity developers, but it's just something that you have to accept. If you open up your Apple script for me, you'll notice on line 27, it says on trigger enter 2D. I left a comment. Here's an example of the comments that you can look at after this class, hopefully help you get a little bit further. I left a comment that says on trigger enter 2D happens whenever we are touched, but only if our collider is marked is trigger. Anybody know what a trigger is?
Like an event will happen when something is triggered?
Yeah, so let's say we're in Legend of Zelda Ocarina of Time. We're walking into the Great Deku Tree and we're gonna go fight Goma. We step through the doorway and the door slams closed and Goma appears and we get eaten alive and stuff.
Is it something that tells the script to react to an if-then script?
No, but kind of. Like you're sort of on the right track. But basically a trigger is a collider. It still collides, but it allows things to pass through it. It still says, hey, I got touched, I got collided with, but it allows things to pass through it. So in that Legend of Zelda example, we would step through the doorway and there's no physical entity stopping us from stepping through that doorway. There's no wall in the way. There's no invisible wall. We can still step through, but it registers that we touched that invisible wall and then it makes the boss appear. So the reason that I point this out is this apple is expecting to be a trigger and not a collider. I have never been sure why Unity doesn't just have two scripts, one called a collider and one called a trigger. Maybe they thought that was too complicated. Instead, they just have a little checkbox. So on our apple, in the Circle Collider 2D, you'll see a tiny checkbox that says is trigger. And if you hit that, such that just the apple is checked on, you will now have a functional version of Snake. Oh, it's probably gonna crash actually. Yep. Amazing. So let's not be scared of our crashes though, right? It will take us some time to get used to our crashes, but only by looking at them and investigating them can we get better at engineering. So what it says is unassigned reference exception. Dennis, didn't we learn what that means?
Unassigned reference exception? That means it's not attached to anything?
Yeah, something in the inspector is not attached. And it says the variable player trail renderer of apple has not been assigned. So we go, okay, of apple, we got to go to the apple. Then we got to look for something called a player trail renderer, which it has right here. And it is, in fact, none. It is not attached. Where is our actual trail renderer that we have to drag and drop in here?
It's on the snake.
Yep, it's on the snake under the trail renderer object. I can actually just drag that trail renderer object, that entire thing, and drop it into that empty box. And Unity will be smart enough to find the trail renderer component on that object and attach it correctly.
Oh, because it makes the tail get longer.
Indeed. The apple needs to know about that. So now, if I hit play, I'm actually playing something equivalent to Snake. The tail gets longer every time I touch something. And there's currently no way for me to lose, but it at least looks like I'm playing Snake. Awesome. Okay, so besides the fact that Rowan's movement is totally broken, Morgan and Dennis, where are you guys at? Good. All right. So what shall we do now? Here's what I think we should do. We're pretty much towards the end of class. So I'm going to describe how to continue on with this project on your own. I'm going to give you some pointers. and the scripts that I have available to you that we have not used yet. So first things first, this is one that all of you could definitely do. I don't know where your experience level is for all of you. Morgan seems to be, a king. All of you guys, all the other people seem awful, but I don't know. The walls need to be added to our world. So right now we can just move off into the edge of the world. We can keep going forever. If we want to make our game a little bit more user-friendly, we can add some walls to our world. So that's something you can definitely do. And all you need to do for that.
Problems.
Oh, what's up, Dennis?
I was saying, I just wrote, because I want to interrupt, that my snake can't eat the apple. It just goes around it.
It hits it?
It hits it and goes around it.
So that is almost definitely that your apple is not a trigger. So click on your apple.
Okay.
And your circle collider component underneath it is an is trigger box there. Click that. Make sure it's on.
Okay. I guess I missed that step. Thank you.
Yeah, it's okay. So yeah, add some walls to your world. All of you can do this. That's easy enough. You just add some images that look like walls, attach a collider to them, and then your snake will run into them and they won't be able to go outside of the world. That one's easy. The next one is really interesting. So these classes are always a balance where I need to create a solution for you that does the game, plays the game, but is not too complicated for somebody to understand. If we were going to make a real correct version of Snake, we would have created what's called a matrix or a 2D array, which basically just means a grid that we traverse. And our tail would be drawn in that array, in that grid, right? And that's why Snake looks so much like a grid when you're moving around, because we're actually doing that. Our game is not a true grid. We just have restricted our movement so that we can only move in one direction at a time. So it kind of looks like a grid. And we did that to simplify the game for all of you. The other way that we have simplified this game that is pretty weird, but I kind of love the solution, is running into the tail. Right now, we'll notice that if we run into this tail, it doesn't matter, right? We don't even touch the tail. We don't collide with it. So do you remember that the trail render is an actual 3D object, right? This is an extruded 3D object in space. That is actually pretty freaking complicated to collide with. What you would have to do is draw a bunch of vertices in the same 3D space as that tail, and then somehow also not collide with the head of the snake. That is something that is way above all of y'all's pay grades as far as engineers at this time. So instead, what we did is something that's really interesting. Let me remember exactly how complicated this script is. Maybe I'll just have you copy it right now. Oh, that is not this one, right? Yeah. Okay. So I will demo it in the other project, and then hopefully you guys can figure it out on your own time. So what we did instead, while I open up the other project, is we made our snake poop. So if I open up the previous snake tester and wait for it to load, what we basically did is we drop little circles into our world every third of a second. So as our snake moves, a little circle appears behind the snake. And I don't know why, when I was trying to demo this to you guys before, it was not behaving correctly, which I wonder if it's broken. Let me just check on the snake. It all sure does look right. Let's turn up the speed and see if it works. So I have these snake poo objects, which I named to mostly try to get a laugh. So I'm going to turn up this alpha so that you can actually see what's happening. So as my snake moves, we'll see that these black circles appear behind me. And as I get longer, more of these circles appear, and more importantly, they last longer. So what's actually happening is it's just dropping a circle in space. It is doing what's called an instantiation. It is spawning a circle in space, so that these circles can actually detect if we run into them. You saw there, if I turn around and ran into the circle, it worked just fine, right? And the circles have a script on them so that for just a moment, they don't collide with my snake. Even though they're spawning on top of my snake, they have their collider turned off for just a second. and then they turn their colliders on themselves a little bit after that. So that way, it's not a problem that they're spawning on top of the head, and it only detects collisions later if I try to run into it. And these circles are told to destroy themselves the same amount of time as the trailer renderer currently is. So remember that we used the time to indicate how long that tail should be. We put it at half a second and it was a pretty short tail. And then we had it at 5 later and it was a pretty long tail. So that those circles are basically doing the exact same thing. They actually only exist as long as the trailer renderer exists. So that way we don't need to do any collisions with the trailer renderer. We only do collisions with these circles. So these are what we're calling snake poos. And the way that we make it so that the player doesn't see them is we turn our snake poos alpha in our color channel here, click on color. We turn the alpha down to 0, which makes them fully transparent so that the player can't actually see them. And it just looks like I'm running into a trail. So this is kind of interesting. One, because it's a much simpler way to do snake. So hopefully you guys can figure that out. There's tons and tons of comments in the scripts themselves. Hopefully that helps you. You can also always message me. I'll give you my email in just a second. The only other thing that you'll need to know about is instantiation and prefabs. In Unity, we can save objects to be reused multiple times as a prefab. In order to do that, I build it out in my inspector. So like I just built this wall, let's say, and then I drag it from the hierarchy into my project, and we'll see that it becomes blue, both here and in the project. And this allows us to duplicate objects very quickly. That is what we call a prefab. So what you'll have to do to make your snake poo work is you'll need to make a snake poo object, which has a snake poo script attached to it, as well as a circle collider, and its alpha has been set to 0. Once you make that snake poo object, you can look at this recording later and follow these steps, hopefully. Once you've made that snake poo object, you're going to drag and drop it into your project folder so that you have a prefab. And I already created a prefab, so it's complaining. Once you have that prefab, you will see that it has its own spot in my hierarchy that I can now mess with. And we'll see that the snake head, the script that I provided for you, is expecting a snake poo prefab, which will actually spit out every third of a second. So that's the way that we made our collisions work for our snake tail. And I will also teach you a couple of more complicated concepts like the prefab, like instantiation. So that is where we're going to leave it for today. There are a few things for me to mention here. First things first, I'm going to be putting up this recording. I will send it out to everybody who signed up on the Eventbrite. But if you need me, I'm more than happy to chat with anybody who needs help. That right there is my email. It's my personal email. Feel free to use it. I also, like I said, run a community called the Indie Game Academy. We teach people to run their own indie studios. So we take our main program, takes 20 students, and basically sorts them into like a gamey Harry Potter. So we have 4 houses, 4 noble houses with noble heritage: House Rogue, House Cleric, House Warrior, and House Ranger. Those houses basically get stuck together out of those group of 20 students. So 5 people per house, and each house actually builds, publishes, produces, and releases an original monetized game together over the course of 3 months. That's our main program. If you would like, because you have now done an event with me, you are welcome to join our community. Let me get that link for you. But the main thing that I want to leave you with here is we have a smaller program coming up that we call IGA Level 2. The main program is IGA Level 3. And this smaller program is meant to teach you basically what you just learned, but much more in depth over the course of a month. So I will share this URL with you, and I'll also put that in the email later. But this is our IGA Level 2 program. You go through 1 month. In that 1 month, you're going to build 2 games, Peggle and Super Mario, and you will actually publish the Super Mario game online. So you'll be putting it up on itch.io, even asking for donations, all the good stuff. The main point of IGA Level 2 is to get you technically acquainted with Unity, building your own games, such that you can move on to Level 3 and actually build out a full game, work with your own little studio, and publish something much bigger. we're running this on August 16th. So if you feel like you got some sense of a taste here, this program is 8 times the length of what we just did tonight, and much more in depth with actual assignments, handouts, and support on our Discord server. So if it sounds interesting, I will drop the link in the chat and email you this a little bit later. Okay. So does anybody have questions about the class itself, like technical support, or about our IGA level 2 or any of our other programs?
When does the IGA level 3 start?
So the next one is going to start in October. So it's actually a little bit ways out. I can definitely ping you about that as well. Any other questions? And Rowan, we can totally dive in, spend a couple minutes here, me and you, get your snake moving. All right. Well, Morgan, Rowan, Dennis, Curtis, thank you for coming along. It's been a fun 2 hours. You will get an email with some of the same information. And thank you for learning some Unity with me.
Thank you for teaching. Thanks for having us.
Yeah, thanks, guys.
Have a good night, everybody.
Thanks, y'all. All right, bye-bye. Rowan, do you want to try to fix stuff? I can't. You might be muted.
Yes, it was.
Yes.
I feel like I can probably fix it myself since this was recorded just by following along again.
Okay.
And I can email you if I can't get it to work.
Okay.
But I usually do courses via recorded videos anyway. So that's actually more my speed, because then I can stop and start and go back and do it all several times over.
Yeah.
But yeah, no, this was great. It made a lot of sense. And considering I've never coded before, it made more sense than I thought it was going to. So
yes,
no worries.
Absolutely. Good. All right. Well, I hope you have a fantastic night then, and I will see you again soon.
Thanks. You too. Bye.
All right. Bye-bye.